So this routing information protocol has got two versions we learned. One is the class full version, the other one is classless. So we are going to see the importance of classless protocol by having a topology like this. Let's take 1, 2, let's say 3 routers, and we got discontinuous network. What is it? We got 10.12.0.0/16 subnet here. Here we got 10.24.0.0/16, and here we have 192.0.0.0/24, and here we got 192.1.1.0/24. These are all subnetted networks. When we have version 1, router 1 will never hear about this network, this 10.24. The reason is, according to RIP on router 1, it has got 10 network, which is directly connected. So router 1 says to the broadcast address, this is version 1 we are talking about, router 1 says to the broadcast address, I got a network which is 0 hop away from me, which is directly connected for me, and whosoever receives it, for them it is 1 hop. Okay, router 2 will receive it, router 2 will learn it, saying 10 is 1 hop on this interface, via this interface. Now when router 2 advertises saying 10.0.0.0 is 1 hop for me, whosoever receives it, for them it is 2 hop. When it advertises like that, router 3 will say, no thanks, no thanks. Why? According to the RIP on router 3, it has got 10.0.0.0 in 0 hop, which means directly connected. And according to R3, it is already advertising whosoever receives from me, for you it is 1 hop. So both router 1 and router 3 thinks that they got same network, 10.0.0.0. So the advertisement coming from R1 will never be learned by R3, because R3 says I have same 10 network with better metric. What is the metric? 0. What you are giving? 2. So lower is preferred. Router 3 says I already know 10. I already have 10. But as soon as you switch to version 2, what happens is there is some change happens in the advertisement. Sorry, this never changes. Oh, there's a change happens in the advertisement. What is that? It will say /16 with this. As a result, router 3 can accept this update. Why? In /16, I have just got 0. In /16, I can have 255 networks here, 1 to 255. So router 3 will accept saying I got only 10.24. All the other 10.1, 10.0, 10.2, 10.3, all those networks are somewhere via router 2. So it learns the update that is coming. But when you say no auto summary, no auto summary. By default, RIP is designed to do summarization. That is why it is saying 10.0.0.0/16. But when you say no auto summary, it will clearly advertise saying I got 10.12 with me. And this will say I got 10.24. So router 3 now learns a clear route information saying I got 10.12.0 from router 2. And locally, this is where RIP. And locally I have 10.24.0.0 connected directly. In short, what I want to say is, by default summarization happens. Even though summarization happens, router 3 will still learn router 1's update if it is version 2, because it is going to say the mask, the prefix length. Because you send the prefix length, router 3 understands that I got one of the network in that prefix length, which is 10.24. So the other balance maybe via router 2.
Yes, sir.
Fine. We are going to now do and see these things, after which we'll get into a few other new stuff in RIP. Let's first fix this classless and classful thing. So this is the IP address planning. We need to assign this IP address bigger before we understand RIP. I'm starting from the left and I got this computer with 10.12.0.1. The mask is going to be 255.255. 255.0.0. The gateway is going to be that routers understand 12.0.2. Right now, I'm going to put it again nicely here, arranged. And when we type this command ipconfig, we see the IP address, the mask, and then the gateway. Let's go to router A. On router A, we got two interface. Interface 00 is down, so I say no shutdown. It has come up. I put the IP address 10. Interface F0/1. Zero. Now, the reason why the interface is still red down is the other end is not up. See, the
Yes, sir.
status is up, but the line protocol is down because of the other end. Let's go to the other end, other route. IP address is 192.168.0.20. Interface of 0/1. IP address is 192.168.1.1. Show IP interface brief. Okay, let's move on to C. Interface F0/1 92.168.1.2. Interface F0/0. The IP address is 10.24.02. Show IP route. You got routes for the directly connected with the mask. Okay. Why this is in two separate lines? Because this is the actual network prefix, but we have subnetted to 24 like this. Whereas this one is not subnetted. 24 is the default mask for 192. So it says there is one subnetted network in this router, and which is 10. This PC need to be assigned with IP address. Right. So I would like to ping the directly connected.
So for this one, it should be subnet mask 24, right? So another 255.
Thank you. Yes.
And also in the previous IP route, the connected one, I just want to know, how did you get the 10.24, the connected one on fast internet 0/0?
Yeah,
Yeah, that one, sir.
this is what we have in the internet interface as the network. Show IP interface brief. This is what the network portion is.
But then the interface is 10.12.0.2, not 24.
See here, I'm showing you the interface.
Okay.
10 or
Oh,
12.
that's RC. Sorry. I was looking at R. Sorry, sir. My
No
mistake.
problem. Now, let us try pinging the directly connected devices. 10, 24. Wait. Okay, I changed to /24 now. Okay, so ping 10, 24, 0, 24, 0, 2. I'm able to ping my gateway. From the gateway, let us ping. Okay, let's go to router B and ping the adjacent routers, the directly connected address 192.168.0.1 pinging. It will ping 192.168.1.2. to ping. For last verification on router 1, I want to ping the PC 10.12.0.1. Let me ping pings. Now what we do not have in router A is route to reach the remote networks, for which we are going to enable version 1 RIP first.
Yes, sir.
So I go here and I say router RIP version, I don't want to say, network 10, network. You cannot specify the mask also. You cannot say 10.12/24, nothing like that. There is no option for you. Even if you say it is going to take it as 10.0.0.0, let me show you that. Let me show you the next router. The next router you see, I'm going to give router RIP network 190. No, I cannot show that one here. I will show it on RC. On RC, if you see, I say router RIP network 10.24. I say what I'm saying is this is not necessary. What I'm doing now is not really necessary. Whether you say 10.24 or 10.0, that is same. It doesn't make anything. You cannot say the subnet mask. There is no option for you to give how many bits or network. So I said 10.24. I want you to see what it has taken. Show IP protocol. You see it has taken as 10.0.0.0 on F00. But did I say 10.0? No, I said 10.24. That's how it works. Even version 2 will do the same thing. In version 2 also, you cannot say the second octet for 10. If you say also, it's not going to consider the second octet. But when they advertise, version 2 can advertise the subnet mask from the interface. Wait for a few minutes, you will see what I'm trying to say. I'm going to say router RIP network 192.168.1.6. Now on RB network 192.168.0.0 and 192.168.1.0. All right, now we got RIP running everywhere. But if you expect routes, go to router A and check show IP route. You are not learning the 10 network. You are learning 192 network because they are two different networks. /24 by default for 192. This is 192.168.0. That is 192.168.1. That is not a subnetted one. So learning that 192.168.1 is not a problem for the RIP running on router 2. Sorry, router A. Now, if you go to router C, same condition. Show IP route, you don't learn 10.12. But do they advertise it? We need to check it. Let's go to router B. Show IP route. This explains you everything. Listen. Router A says, I got an advertisement about 10.0/8. It's not saying /24. It says I learned 10.0 network from both this guy 192.168.0.1, which is router A, and also from this guy. What do you understand from this? We understand that the mask /24 is not revealed to be. Is there any other proof? Yes, I can show you. Debug IP RIP. Debug is a command that will dig deep and show you the actual conversation that goes behind the screen, like advertisement, so that if there is any bug, you can fix it. The actual advertisements that the reapers sharing in between the routers are not shown by default, but it is happening right behind. Every 30-second the advertisement goes and the other guy receives it. As I said earlier, it uses a broadcast address and it will advertise because it is this is version 1 by default. Let's check it. RIP protocol debugging is on. Look at this. This router B is sending version 1 update to 225, 255, 255. VR router 00. On router 00, it is advertising 192.168.1.0. This network is going this side. The network which is between router B and C is given to router A. All right? And it is receiving version 1 update. Please understand. Let me stop the debug for a while. Just keep on jumping. You all undebug all. You means undebug. You can also type the complete word undebug space all. Stop all the debug. That's the meaning. What I'm trying to show here is router B receives version 1 update from this guy. Who is this guy? This is router C. You see the address 1.2. On which interface? This F01 interface on B receives an update about 10 network. Look at this, how the update is coming. It simply comes with no mask in it. There is no mention about 24. There is no mask mention, nothing. Simply it says 10 I have. For me it is 1 hop. That's what it says. Router C says for you it is 1 hop. For you it is 1 hop. Why? For router C it is 0. That's why it says for you, whoever receives it. For you it is 1 hop. The similar update is also received from router A. Same metric. Both are saying for you it is 1 hop. That's the reason why router B learned both 1 and 1. 1 hop to reach 10. And what is this? Administrative distance, the trust level for it. Now, according to router B, 10 network is via router A as well as router B. Sorry, router C. Router A as well as router C. So if you ping now this 10.12, if you try from here pinging 10.12.0.1, which is really this computer, but the packet will not be delivered to that computer. Because according to router B, 10 is on both this direction and this direction. So one packet will go this way and it will ping. The other packet will go this way, but there is no real 10.12, so it gets dropped. It goes up to router C and gets dropped. The third packet pings, the fourth packet drops. You want to see? Let me show you. Ping 10.12.0.1. Sorry, I forgot to, I mistakenly hit enter without putting the dot there. Whenever you make mistake, it is taking very serious. It is not thinking that it's not really saying blaming you. You made a mistake. What it is doing is it thinks that this must be some command, a new command. So it is searching everywhere, domain, server, by sending a broadcast asking, hey, anyone knows anything about this command?
Yes, sir.
We can tell router not to do this because it's going to make you wait for 60 seconds. 60 seconds, it won't come out. 60 seconds, it will be searching, waiting for someone to respond to this query, but no one is going to respond because it's not a command. How do you avoid this? To avoid this, we need to say no IP domain lookup. After you say this, if you make the same mistake, it won't make you to wait. You say, I'm going to make any mistake, it won't make you to wait. So now I'm going to say, you see, one packet reaches, second packet unreachable. One packet reaches, second packet unreachable. Third packet reached, sorry, unreachable, fourth packet reached. It is because whichever the packet that went to the left successfully pinged. The one which went to the right dropped. See, the first packet went to the right, dropped. Left ping, right drop, left ping, right drop. U means unroutable. Alright, so this is the issue because of class full protocol. Class full protocol cannot give you proper routing.
Yes, sir.
In router B, you at least got some information that 10 is on the left as well as on the right. This is left, this is right. But on router A, you have no information about the network which is on the right, 10 or 24. And also from the debug, you learned two things. One, when the advertisement is done, no subnet mask is advertised. Two, it uses broadcast address 255, 255, 255, 255. Now we are going to switch to version 2 to solve the problem. The command is very simple, but before that I want to show you here. See, show IP protocol. This is the command which we will use to see what all routing protocols that are currently enabled. We right now have in this router only one routing protocol which is called RIP. We learned that every 30 seconds the periodic update is sent, and 180 seconds is the time it holds even if there is no update. And after 180 second only, say after 180 second only, it makes it as possibly down, invalid. So the whole time is 180 second. And after learning a route as possibly down, it takes another 60 second, which is 240 in total. 180 plus 60 is 240 to flush it out. What are the other things we learn? We learn that this is redistributing RIP, meaning it learns route from one RIP and give to other RIP routers. For sending, it is using version 1 update. Because we don't have version 2 running, we see that it is version 1. So sending will be version 1. Version 1 is using what? Broadcast. But receiving, it is ready to receive any version. What does it mean? Because it is using broadcast, means all, receiving from a multicast is also possible. Version 2 only uses multicast. Broadcast can understand multicast very well. So receiving version can be a version 1, which is broadcast, can also be version 2. That is what you see here. Receiving can be version 2 or 1, that doesn't matter, but sending is going to be only version 1. Version 2 means what? It is multicast. So it is ready to receive from multicast, but not ready to give version 2 update. It will send you a broadcast. But on the version 2 enabled router, only version 2 can be received and sent. Version 1 cannot be received. Why? Version 2 means only multicast. Broadcast is not allowed. Let me show you that.
Only the group members can receive.
Yeah. Let me show you that router RIP version 2. That's all I said. Now if you see show IP protocol, you see this says I can only receive those traffic that is sent to a multicast, and I will also send to a multicast, which is 224.0.0.9. Now I would like to show you, see other routers we have not enabled version 2. Here I want to show you the difference, debug, IP, RIP. Okay, you see it started advertising along with the mask on the interface. So not mask on the interface, the actual mask of that 192 is 24. Here the actual mask of 10 is 8. Earlier it was not even sending this mask. Now it sends the mask. Not only that, it is using a multicast. Let me stop the debug because this is jumping. Now to send, it uses version 2, which is 224.0.0.9 multicast. Earlier when you saw, it was sending using 255.255.255.255. But this time you see, it is very clearly saying that it is sending using 224.0.0.9. And this time while sending, it is also using mask. It may not be the actual mask on the interface, but it is at least sending the mask. It's sending the mask. And when a packet is received from router B, this is router B's address, isn't it? Router B 192.168.0.2. Because router B is running version 1, which is using a destination address as the broadcast address, router A says, for me it is an illegal version. I don't receive from a broadcast. I don't receive any packet that is sent to a broadcast, so I'm ignoring it. I'm ignoring it. I opened the packet and I found it as an illegal version. So I'm ignoring it. So it's not going to learn. So on router A's routing table, if you check show IP route, nothing. This is old one. This is dying. Look at this. See the timer. Every 30 seconds the update should come, no? See, it is not updated for last 2 minutes and 57 seconds. It is going to be possibly, look at this, it's possibly down now. Once it reaches 3 minutes, 180 seconds, it is possibly down. It's an old update before we switch to version 2. This was there in the routing table. Right now, it is ignoring this update. Right now, it is ignoring any update. So don't think it is learned now. It is going down. In few seconds, it's going to disappear from the routing table. It's only 60 seconds, after making this possible down, it should be there. 240th second, it should flash out. If it is not flash, this is simulator. If it's not flashing out, what we can do is we can say clear IP route start. Means clear all the routing table entries and learn fresh. So when you learn fresh, you won't see it. Unless new update comes, nothing can be learned. Okay, so between router B and router A, the updates are going, but router A is not ready to receive the update from router B because router B is class full. It is sending to a broadcaster. But for a surprise, you'll be learning from router A and router B. Listen, you don't have any problem in learning. You see the latest update, latest, 23 seconds ago. See, 2 seconds ago. Which means it is every 30 seconds it is getting update from router A. Why? Because I told you version 1 can receive from version 2. Show IP protocol. It can receive from version 2, no problem. But in the routing table, you don't see any mask. It's simply having the default mask. Okay, now we have to switch to version 2 on all the routers. Otherwise, router A will never learn from router B. Let me make it as version 2. Router version 2. Router C also, I'll do the same. Router RIP version. After changing, you will see the routes. Let me go to router A now. You see, I learned 192.168.1.0 and on router C show IP route. I've learned 192.168.0.0. Now let's say debug IP RIP to see what it is learning. You see, router B is advertising only 192.168.0.0. So router A only receives this one update. It is not learning anything about the network which is behind router A. Why? The reason is, according to router B, both the side it has got this 10 network, both sides. There is no difference because by default it summarizes and sends. You see, show IP protocol, automatic network summarization is in effect. It's effective. So when I say debug, or when you go to router B and see the debugs, both from router A and router C, it receives the same. See, this is from router C. It receives this information with one hop, and you need to now look for updates from router A. Wait for some time. Okay, from router A, you will receive the same info. Same info. So there is a split horizon. You remember, if 10 is learned on one interface, you cannot advertise on the same interface. So what happens is, this is not given to this interface, this is not given to this interface, because it's the same info. Split horizon stops them. I would like to show you the split horizon on the interface. Show interface F00. Show IP interface. IP. Yes, you need to remove interface. Okay. You see here the split horizon is enabled on all interface. The command that I typed to see this is show IP interface. Okay, what I'm going to do is I need to do auto summarization cancel. I'm going to cancel this. Router RIP, no auto summary. Likewise, I'll do it on RC. Router RIP, no auto summary. Likewise on router P, router RIP, no. Now if you see, the advertisement will be different. Oh, I made a mistake here with searching. I should have said no IP domain lookup on just routers. Yeah, I need to wait. No IP domain lookup will solve this issue. We put on router B, but we did not do it on router A and C.
Yes, sir.
Okay, now I'm going to say debug IP RIP. You will see, along with the mask, it will also add the prefix length, not the default mask. It's going to say /24 this time, not 8. Look at this. It is receiving version 2 from B with proper info. It says 10.24 is 2 hop away. It receives. And it also sending. I want to see here. It is okay. Wait, some more. I want to see. Okay. Sending version 2. Look at this. It sends. It sends with the proper mask. It says I got 10.12. It's 24 mask. Because I said no auto summary. Look at this. Show IP protocol will also show that it is not in effect now. Summarization is not in effect. As a result, when router B learns, there is very clear subnet information in the routing table now. It says I got 10.12 on F00 interface from router 1 and 10.24 on F01 interface. And what is this thing? This thing is dying. These are old entries. It is dying already, almost going to die. See, this is 24, no, but now it won't be 20. It is 26, 20, Means it's getting fresh update. But this one already gone to possibly down, so no need to worry, it won't be used. Now, when I go to router 3C and type show IP route, I can see now the route very clearly saying 10.12 is hop. 10.24 is directly connected. So now very well you can ping from here 10.24.0.1, which is on the last. You already pinged left to right, and right to left is also 10.12.0.1 is possible. Right, so we have learned that version 2 and no auto summary, these two things, will be solving the discontinuous network issue.
Okay, so basically you need two things, like what you said is one is the version
Yeah.
2, and then you need to have auto
No
summary.
auto
So
summary.
no, yeah, no auto summary, so you can ping from one side to another
Oh,
side,
very well said.
and you can reach and you can send the packets to the destination.
Right. You see, when you type show running, you'll see what all I configure under RIP. Version 2, this network, and no auto summary. Yeah. So this is router A configuration. Let me show you router B configuration. Show running. Go down, you will find the configuration of RIP which we have done here.
So
Uh,
question, do you also need to have no auto summary on router B or not
it
required?
is good to have on every router because this also has, okay, no, actually in this scenario it is not required,
In this scenario, yes, okay.
but whenever you have classless network, it is always good to cancel the summarization to have
Okay.
clear network.
Okay. So if that's the case, then the rule that we spoke about yesterday, like split horizon rule, doesn't apply,
Now
isn't
split
it?
horizon is still applied. This is 10.12 this side. This is
Oh
10.24 this
yes,
side.
okay,
Split
okay,
horizon
yes,
is
okay,
always there. Okay, so
okay.
now we have seen the difference between version 1 and version 2. Now, there are a few more things that we need to see in RIP, like that poison reverse, route poisoning I want to show you. And then authentication in RIP. The routing protocols needs to authenticate before accepting any update. Before receiving update from router B, it needs to authenticate and then accept. Otherwise, someone will pretend like router B and give you the wrong route information, and your router will learn wrong routes. The route may be taking the packet to the attacker's network, which is dangerous. So authentication is really very important. So that is the other thing that we need to see. And the third one that I want to show you here is what if one of the router now never supports version 2? One of the router never supports version 2. Assume supports only version 1, but the other two supports version 2. Then how we are going to accommodate? And all those things are these are the exception things that are available. And fourthly, what we are going to see is how to change those timers, that 30-second, 180-second, 240-second. I told you if you wish to change, you can change. So these are the things that are left in our RIP portion to finish the topic completely, not just CCNA level, right? So we'll see that after a break. All right. So we learned that if a network goes down, the other routers will be informed about this network going down. For example, I have 10.24 here. This 10.24 is directly connected to router C. Show IP route, you can see that it's directly connected. And on router B, it is learned as one hop away. Okay, here we go. 10.24 is one hop away. And on router A, it is two hop away. 2 hop away. How router A knows that it is 2 hop away? That is how B will advertise. B will say, for me it is 1 hop, whoever receives it, for you 2 hop. Router C will say, for me it is 0 hop, whoever receives it, it's 1 hop. That's how B learned as 1, A learned as 2. Now, let's go and shut down this computer. I'm going to physically off this here. So the link went down.
Yes,
And
sir.
then now when you check the routing table, 10.24 disappeared. Now on router B, it is possibly down. In the real device, it won't be immediately possibly down. It will wait for 180 seconds. Now, because this is saying possibly down, router A will also now say possibly down. Look at this. How it is possible? How this knows so quickly? As soon as router B waited 180 seconds and understand that it is possibly down, it will start advertising with 16 hop. See debug IP RIP. You will see that when 110.24 is advertised, it will advertise with 16 hops. Come on.
So does it straight away put 16 and
Yes.
advertise, or does
Yes.
it wait until 180 seconds and then?
No, I repeatedly say this is a simulator.
Okay.
Router B will wait, router C will wait for 180 seconds, and then it will make it as possibly down. That is the meaning that the metric is now changing to 16. When it says possibly down after 180 seconds, see it says 16, metric is 16. Metric is 16.
Yes, sir.
And when A receives with 16, A will also switch it to possibly down. During this period of 180 seconds, between A and B, there won't be any sign of network gone down. Meaning B will, even though B is not receiving update for 180 seconds, B will keep continuing the sending of update every 30 seconds. Did you understand what I said?
Yes, sir.
Still, I allow to repeat again. This has gone down, so this will wait for, this will remove immediately from the routing table because it's directly connected. And it will stop sending update because it is gone. And this will wait for 180 seconds. During this 180 seconds, there are many 30 seconds of, right? In 3 minutes, there are many 30 seconds, at least 6 30 seconds. And there will be 6 update about 10.24 saying it is still available. So according to router A, it is not waiting. It is receiving update every 30 seconds as if nothing went wrong. But only B knows that something is wrong. And it is patiently waiting for the recovery, but the recovery never happens even after 3 minutes. If recovery would happen, then it is B's responsibility to say, hey, it's no more, by putting 16 hops. It turns the routing table's entry as possibly down and puts 16 hop instead of 2 hops. And when this receives 16 hop, immediately, without no need to wait here, this router A, no need to wait, as soon as it receives 16, because this guy has already waited, he puts 16. As soon as this receives 16 for network 10.24, this will immediately turn it into possibly down. And from there, another, see, it's gone. Right? Gone. It removes after 240 seconds. So this is what road poisoning. Poison reverse, during the time it will also go back to the source to reconfirm. Let me see whether we see that on this sending update on F01. Look at this. No, we don't see. We don't see. Do we have it here? Where it is? F00. Poison reverse is going back like on F01 to reconfirm. That very first time when it found us possibly down, it will do that. Not every time. First time. Fine. So that's about route poisoning, poison reverse. What next is the authentication. Let me bring this up. Ping 101201. Okay, I'm able to ping. Now, authentication is very important for all routing protocols. We're going to do authentication in between RA and RB. First thing is you need to create a keychain. Keychain may have more than one keys. Why should I have more than one keys? So that you can have the first key from today to tomorrow, second key from tomorrow to day after tomorrow, or first key for next 6 months, second key from the 7th month to the last month of the year. So even if first key compromised, it won't be for the whole year, for the whole year, because it's going to change. So you can also set, like 12 passwords for 12 months. So automatically when the date comes, it will switch to new password. So we need more than one keys if you want to have new keys changing for every month or every week or every 3 months, 6 months, like that. So we need the keychain. And give any name. I'm going to say this is a keychain for router between router A to router B. The name can be anything. Key ID. Key ID. Okay, we need to give a number. The first key, I want to have key as Cisco. No, key string is the keyword. Cisco 123. And I can say the period when I want to use this as a key. Send lifetime. When to when. From now, do I have now? Option. Okay, I need to say the start time. Let's say 07/28/00. From this time, what date? 05. What month? May. What year? 2023. Till what date? I can specify a date. And I can say duration. Seconds, I don't need duration. I can say similar date like 07, blah, blah. And what I'm going to say is instead of May, I'm going to make it as May, June. Right? Enter. Wait. What is this? Okay, first comes the. It was right, no? 05. Okay. And the month is June. June. Here is 2023. That's it. So this password is going to be valid only this period. Now let's go to the other password. Key 2. Oh, one more thing. Receive lifetime also, I should say. In key 1, I only said sending time. Send lifetime. Same password if someone is sending. What is the accept lifetime? What is the accept lifetime or receive lifetime? I want to say the same thing. If someone is giving that password, they should be giving only during this period. Boom. Likewise, you can have multiple keys. Now I will show you now show run. You see we have this key. Key 2, likewise, you can have another password and you can have another timing. I'm not going to do that now. So we have a key chain with one key now as of now. And I'm going to copy the same to the other route. Now, what next is we need to apply this to the interface where RIP is running. We have just created a keychain. We need to apply this. Interface F0/1 IP RIP. No need. IP authentication RIP. Okay, IP authentication keychain. What is the keychain name that I gave? RA-B. Keychain. Oh no, this is not the command. This is the EIGRP command. Okay, for RIP it is IP. Okay, RIP. No, IP RIP. IP. The command is not available. Let me try this. There may be some option globally. Authentication. No. Maybe this is the limitation of the simulator. Let me quickly go and check it on the real device. In the simulator, we did not find that command to enable RIP authentication because it's a simulator. But here I must see that command. It should be there. Let's see. So, see when you go to interface F00, IP RIP, you see, look at this. This is the command. This was not available there in that packet tracer route. In here, if you put that same command, interface F00, IP RIP, you see there is no command called RIP first of all. Whereas here we clearly have that IP RIP authentication. I can say keychain for RIP and the keychain name that we created. And then IP RIP authentication mode. It supports two types of authentication. One is clear text authentication, the other one is MD5 authentication. What is it? Clear text authentication will send a simple password without any encryption. If someone will sniff in the path with some sniffing tools like Wireshark, they will clearly see the password. But when you use MD5, the password will not be visible for them in a clear text. It will be in a ciphertext. We'll do one thing better for authentication. Let's use this topology. I'll own these routers and we'll test authentication between R1 and R2.
Yes, sir.
And currently I'm running a protocol called OSPF. I'm going to remove that. See, right now show IP protocol, I have OSPF running here. To remove all the routing protocol, there is one easy command, no IP routing. This will remove all the routing protocol and I put the routing back. Now if you go and verify show IP protocol, there is no protocol. RIP is removed. Sorry, OSPF is removed. Likewise, I'll go to router 2. See, instead of removing OSPF, saying no router OSPF 1, this will also remove the protocol. Show IP protocol now, so it's removed. Instead of doing like that, if I have many routing protocols, that one command no IP routing will remove all the routing protocols. Fine, you can follow any one, whichever you like. Now on R1, show run interface F00. Even though OSPF is removed, the authentication of OSPF which I enabled is still there. And those commands I need to remove manually. Interface F00, I say no, this, no, this, no, this. Alright, now if you verify the same command, there is no other than IP address. No authentication, no SPF, nothing. Likewise on R2. See, actually the protocol is gone. Show IP protocol, there is no protocol. Show IP OSPF interface brief, there is no OSPF running interface. But that's an additional command that I have put in the previous class, the OSPF class. The authentication commands, those need to be removed manually. Show run interface F00. Done. Okay, the OSPF is completely gone. We are going to enable RIP. Right now there is no protocol. I'm going to enable RIP. Here I say router RIP version 2, network 10, network 2. You see, I have a loopback interface, and then I have got 10 network. No auto summary. Right. Let me also go to router 1, router RIP version 2, network 1.0.0.0, 10. No auto summary. Alright, now what is next is we will learn the routes. Show IP route. You will learn two network shortly. Okay, we learned it. We have learned it. Now if you ping, definitely the ping is going to happen. Say I'm pinging to what is the destination of the packet that I generated? Please answer. I'm pinging to. What is the destination of the packet that the PC, the laptops, or the router generates? What is the destination of the packet?
You're pinging. Destination is the 10.123.0.3.
please understand here. What am I pinging?
Oh, you're pinging the router
What is the address I'm pinging?
R1.
What is the
Oh, the address is
then how the destination will be
2.2.2.0.
10.123.03? Whatever the address that you ping is what going to become the destination of the packet, right?
Yes.
What will be the source of the packet?
The R1, which is the
Well said. That is
10.123.0.1.
correct. When you ping from R1, the exit interface becomes the source, and the address to
Yes.
which you ping is becoming the destination. Let's see that. I'll sniff and
Yes.
show you this packet. I'll sniff with a sniffer. I can capture the packet and I can show you here. Okay, so I'm going to ping now once again with this. Ping again, you see? Ping. Okay, now if you see here, the source is, as you say, 10.1.0.1, and the destination is 2.2.2.2. And what protocol it is? ICMP. Yeah? Internet Control Messaging Protocol. I'm not able to hear you. Okay, it is ICMP.
Oh, sorry, sir. I was on mute. ICMP
And
protocol, the ping uses
okay.
that protocol.
So when I was pinging, let me ping again. The source is 10.0.0.1 and the destination is 2.2.2.2. But now I'm going to ping with the source 1.1.1.1.1. Now you see the source is 1.1.1.1 and destination is 2.2.2.2. You understood? You have a command called source command. You can source it with an address. The reason why I want to source it with this address is if I'll get a response, which means router 2 knows the route to reach 1.1.1.1.1. Otherwise, I will not get a reply, right? When I am sourcing with 1.1.1.1.1, router 2 should respond to whom? 1.1.1.1, which means router 2 knows the route. That's why I get the response. So I no need to go to router 2 and check whether router 2 has got a route to reach 1.1.1.1.1. From here itself, I'll know router 2 has got the route. How? Because when I'm pinging from this address, router 2 is able to respond me.
Yes.
Show IP route. So instead of checking like this, whether it is there or not, I just pinged from there and tested it. You understood that, right?
Yes.
Okay. So you learned the source command now. Source command. Next. We will now enable authentication. As usual, we need to create a keychain. I think we have the keychain already on the other simulator. We'll copy from there to reduce the time. Show run. I'm going to copy from here. Okay, 5th of May. So no problem. I can put it here. Done. Likewise, I'll put it on R1. Right, I was checking by typing show clock whether the clock shows this date and year which I mentioned here. If this is in different date, then even if you enable authentication, it won't be effective. You understand that? The local clock should match with the authentication clock. I'm unable to hear you. I think you are in mute again.
Yes,
Okay,
sir.
now let us go and apply this authentication keychain on the interface. F00 IP RIP authentication keychain. The keychain name is this one. And then IP RIP authentication means I'm enabling just the mode text. Text mode. What is this? Text mode means plain text. Plain text. Now, if you go and check the sniffer, you see the packet coming from router 1. This is 10.123.0.1 router 1, and you go under RIP, RIP. When you go under RIP, you see RIP is advertising this 1111 with 1 metric wait. I want to see the authentication. Still, we have not reached. I'm waiting for more new updates. This is from router 2. Router 2 will not have any authentication. Now, next packet coming from router 1, I'm expecting with authentication. Okay, here is router 1 packet. Router 1 packet. This is the advertisement that it is doing. Where is the authentication? I don't see the authentication field here. But anyway, if you see now, because we have enabled authentication on this side, R2 routing table, if you check show IP route, it still get the valid route. How come? Wait, 26, 28, 29, 31, which means the update is coming fine. There is no problem in receiving. What about R1 show IP route? Okay, see, this is dying. Router 1 is not accepting any update from router 2 now, because the update coming from router 2 is not having any authentication in it. This is the proof, you see. You see, it's possibly down now. It was waiting. You remember, you see that? It was waiting for almost 3 minutes, and then only it has put it into possibly down. Okay, yes. So the reason is the authentication is not in place. Let's go and apply the authentication. I go here and say router RIP. Sorry, not router RIP. Interface F00 IP RIP authentication keychain. The keychain name is this is it, and then IP RIP authentication mode. Text. Okay, both the side I have enabled authentication. Now, whatever router 2 gives, router 1 will accept. Router 2 is advertising about 22222 with a metric of 1. And if I go now there on R1, it was shown earlier possibly down, but now look at this. It is gone. Wait some time, it will come back again. It will come. I've enabled authentication on either side now. The authentication should match on either side. Debug IP packet, debug IP RIP. Let me see what's happening behind. Why I'm not learning the routes after enabling authentication. Ignore packet to invalid authentication. How? How? Why it is invalid? I put the same password. Ignoring packet from one. Source from one others. Okay, no problem. It says some invalid. Let me see why. Show run section keychain. Okay, key string is Cisco123. What about on R2? Show run section keychain. Cisco123. The password is same because we cut and paste. Let me try doing one more thing. Interface F00. I'll say authentication mode. Instead of text, I'm going to say MD5, message digest. Okay, so I'll do this on both sides, R1 and R2. The reason why I'm doing this is I can see something on the Wireshark to troubleshoot. Okay. I think there is some filtering happening. Authentication field is not even visible. I think the switch is filtering all those things. I need to remove the switch and connect it directly. Wait, let me see. If it is not coming, that's what I'm going to do. Show IP route, no route, debug IP RIP. The authentication values are being removed by someone in the middle. I think the switch is removing it. Invalid authentication again. So the problem may be this one. I delete this switch and I connect it directly. All right, now let's see. Let me capture. I'll close this old one. I'll capture here now. Okay, there's a RIP packet coming here. Even now I don't see any authentication. Let me go and check debug IP RIP. Again, invalid authentication. Let me do the authentication from the beginning. Okay, interface F0/0. I'm going to remove those two comments to show run section or do show run interface F00. I'm removing these authentication lines that I created given earlier. What happened? Okay. Likewise on R2, I want to remove show run interface F00. Okay, so what I'm going to see is the roots. I should see the root now. Show IP route. I see the root because I removed authentication, which means there is no problem with RIP. The problem is with the authentication. Let's create a new keychain. Keychain. Mahesh. Key ID1. Key string. I'll give key string as nice. I'm not going to say start date, end date, and all, which means whenever I apply, it should start. Sorry. Now I'll go to interface F00 and say IP RIP authentication keychain, IP RIP authentication mode text. I'll repeat the same thing on here. Interface F00 IP RIP authentication keychain. We did not create any keychain. Let's create keychain. We created only here. This name is not necessary to match, so I'm going to say keychain J, key ID 1. The key string should match. Key string is nice. Now we go under the interface again F00, IP RIP authentication keychain J, IP RIP authentication mode text. Boom. So we have configured the authentication same on either side. And let me debug now. Debug IP RIP. Okay, look at this. Received packet with the text authentication. Nice. This is working fine. Okay, now it is working fine. Let me see the capture here. Okay, look at this. This is what I was expecting. You can see even the password, nice, in the capture. Not only in the capture, even in the debug, we were able to see. All right,
Yes, sir.
so we want MD5 authentication to avoid this leakage of our password. So I'm going to say, hey, no, before that, I want to show you the route. Show IP route. You see, you learned the route. You can ping 11111 with a source 2222, which means both side authentication is working fine. Show IP route. You can see the timers are not more than 30 seconds. 25, 26, 27, 28, 04, which means update has come every 30 seconds. Oh, to avoid from someone knowing my password, I have to enable MD5 authentication. I go to the interface and say instead of more text, I'm going to say MD5. Also on router 1, I'll say that same. MD5. As a result, what happens is, even in the debug, you cannot see debug IP RIP. Okay, you will not see anywhere password. You see MD5 authentication. It's not showing the password. And when you go to this capture, here also you will see ciphertext. You see message digest. You cannot see the password anywhere. You know, if you go under the authentication, you'll see only the ciphertext. This is the password. Nice. Can you guess nice from this? Not possible. It's a hash value. Yeah. Fine. So this is authentication story. Now one last topic. Two more topics are left. One is how to change those timers. The other one is how to have different versions talk each other. As I said earlier, one router don't support version 2. but the other one supports. So there are three routers. The middle router and the left hand side router supports version 2, but the right hand side router supports only version 1. Then how you manage to talk to version 1 from version 2? That is one thing that is missing. The other one that we need to see is the timers that we need to know how to change them. Right, those two things we'll see in the next.